Recently, I wanted to go camping. I bought myself one of these Bellman steamers. These are really great as a cheap way to get into steaming milk for espresso. There's actually a different version of the Bellman that's for making espresso, which is like a mocha pot version. The steamer version seems to have the same basket inside that the coffee would normally sit into. And I think this is part of the reason why I think this design has a fundamental problem. The problem is, when you start, this is full of air. As you heat it up, in a normal boiler, what happens is, in the top of the boiler, they have an anti-vacuum valve at the top. And as the steam starts to build up and the air expands, it all gets pushed out of the anti-vacuum valve at the top. So that you end up with all of the air being pushed out, and it's not until the steam reaches the valve that the valve closes off. So at that point, you only have steam or water vapour inside this chamber, and then it continues to heat up and build up pressure. So when you open the valve, you get just steam coming out. With the Bellman, because you start off with it all full of air, and because the bleed is not right at the top, you end up with, as soon as you open the valve, you end up with a lot of air and steam coming out. And that just makes it impossible to texture the milk properly. I think it's exacerbated by this. This is really part of the design that was for the espresso making version of it, but it's integral for the seal. You can't just remove this part because this won't seal properly on here. So you have to keep it. Originally it comes with just these 5 holes, and air obviously gets trapped in there. I think what happens is when you steam, a bit of the air just gets entrained in the steam flow and it just keeps coming out. It's almost impossible to get rid of it all. So what I thought might be a good idea was to drill holes in here. So this means that now the air can go through these holes as it expands. It can come out these holes, and then it can come out through this valve, which you leave open. So you leave this open as you're heating it up. After about a few minutes, I tried it with 5 minutes, but maybe even fewer minutes, all of the air would have come out, and you can close the valve and then start building up pressure. So yeah, basically this modification was just putting 4 12mm holes here, and I found now that it works heaps better. So I can show you some of the experimentation I did. This is what I used for drilling the holes. So this is stainless steel. It's quite hard. It's difficult to drill through. So you want to be careful when you do this. You take the O-ring off, hold it in a vise, put masking tape around it or some kind of tape, and center punch where you want the hole to start. Probably pilot drill with a small hole, and then use these step drills to drill through, and then afterwards file it to make sure there's no sharp edges or bits of metal swarf in there. That's all it takes. So I found that modification suddenly made this Bellman work much, much better for me. So now the process is you put it on the burner with a little bit of water in, so maybe filled up to here somewhere. You leave this open for about 5 minutes, and that pushes all of the air out. You can actually see the air coming out, and it starts to get steamy after a few minutes. So when it's all steamy, then you close the valve off. You keep heating until the pressure relief valve starts releasing steam, so then you're fully up to pressure, all the air is gone. Then you can open the valve as normally and steam your milk. So I hope you enjoy that hack. I'll show some of the results of when I tested it on the stove after this. Enjoy. So what I'm going to try first is, before I drill the holes, I just want to try seeing how much air I get. So what I'm going to do is tear this off. I'm going to put in a measured amount of boiling water. So I'll just bring that kettle back to the boil. Okay, I'll pour some water in. There, it's 250 millilitres of water. So I'll immediately assemble it. Screw it up nice and tight. Got to make sure there's no gap there. We'll open this up. We'll put it on the gas. And what I'll do now is start a timer. Okay, so we're at 2.5 minutes now. You can see there's still a lot of air bubbles coming out. Okay, we're at 3.5 minutes now. We still have quite a few air bubbles coming out. Okay, now we're approaching 5 minutes. So there's still air bubbles, but not too many air bubbles now. So that's when I would normally think about closing the valve, and now just letting it heat up until the pressure relief valve starts relieving pressure, indicating that it's at full pressure. So now we're getting pressure relief valves working. So I'll turn off the gas. I'll open this until it stops venting. And now we'll see how much air we've got. So you get an idea with the bubbles how much air we've still got in here. So we'll try this again after I've drilled some holes in that top section and see how much difference it makes. So now I've cut some holes in here. They're 4 12mm holes. So what should happen now is, as it's heating, the air should come up through here and out these holes. So it should be more mixed, is what I'm hoping, so that the air will come out in one go. So we'll boil some water, give it another shot, and try and repeat the same test as accurately as we can. Reassemble it. Screw this on top. We'll open the valve. Come over here. Put the gas on. Start our timer. And we'll try and do what we did last time. Eventually it will create steam. The steam should build up and push the air up, right out, and instead of the air being caught in this central area like before, I'm hoping more of the air will come out during this first heat up stage. 2.5 minute mark. This is how much air comes out. Now at the 3-minute mark. And I think this might be working. There's hardly any air coming out now. I can barely see any air coming out at 4 minutes. Four and a half minutes. Again, no air. Okay, so let's close the tap now and we'll let it go until the pressure relief valve fires. Okay, so the pressure relief valve's just going now, 8.5 minutes. Turn the gas off. You can see nice steam there. And there's no bubbles. So now we're heated without any air bubbles. We should be able to steam milk properly now. I think that's a win. Yeah, I think that's good. So what I did, by drilling holes in that bit in the middle, which really shouldn't even be there in this design, but I think it's there because it's used in the espresso maker, the mocha pot version of this, where you can make the actual coffee as well. In that case, you need to have the basket holder. With this design for the steamer, they've kept the thing the basket of coffee sits in, but I think it just meant that it wasn't pushing the air out properly at the start because it's all getting caught up in that little holder, and by drilling those big holes in there, I've made it so now the air can get pushed out more easily. So I think now, if I leave this tap open for the first 5 minutes of heating, then close it, I would have removed all of the air. Maybe if I do some more tests, we might find I don't even need to leave it 5 minutes. Maybe it's quicker than that. But next test we'll be trying it with some milk. Okay, so with the same startup arrangement, I've prepared it. Let's try texture some milk and see how it goes. Almost there. Okay, let's clean that nozzle. Alright, let's see what our milk looks like. Okay, bit of a terrible pour, but still, you can see that there's no big bubbles. Looks like we've got a good centimetre of foamed milk or microfoam milk on the top. So there we have it. That's a win.